Okay, this is my first live stream. I'm experimenting with the software, so I'm not really 100% sure that everything's going to work just right, but I wanted to make a quick video to show you something really cool that you can see on radar and on the satellite view. So today is Thursday, July 19th. Early this morning, overnight about well, it was about 11 p.m. yesterday, so June 18th. The Spaceship X was doing some test thing, and the rocket ship exploded on the launch pad. I don't think that I'm allowed to show you the footage without getting permission, but I left a link to it in the description, and you can see it on tons of news sites. So go look at that so that you can see how massive this explosion was. When I first saw this radar, I thought that it was the actual rocket that was taking off and flying into space, and that you could see it track through the sky down in Texas from the launch pad. And I thought that was pretty cool. And then I learned that it was an explosion, and it was even more incredible that of how much you can see on radar. And even though it was at night, so there's no visible satellite imagery, right? There's no light when the sun's not shining on the Earth, but there are other channels in the satellite like infrared, where it can pick up heat changes, and so you can just barely make it out if you know where to look. So check this out. This is a radar website. It's called Radar Omega, and right now I'm zoomed in on Texas, but let me back out and just show you where exactly we are. All right, so here's the US. Let me turn off some of these features to clean it up a little bit. Display, data overlay. Let's turn off surface fronts. Let's turn off storm reports. Let's turn off spotter network. Let's turn off the cyclone port network. Okay, and that's pretty clean. I think we can turn off one more setting to make it look nice. Severe weather alerts, I believe. If we turn off these watches, I think that'll clean up the screen. Still have one showing. All right, I'll leave these watches on. Okay, so anyway, here's the US. I used the black background because at night it really makes things dramatic. Right now, the radar should be locked in at 12:39 a.m. if you look down here. So let's just go here with everything zoomed out. And SpaceX is here right at the very southern tip of Texas. And even at this zoomed out version, you can see starting from this southeasternmost tip of Texas, as I drag the timeline to the right, you can see a little light colored streak coming across the sky. What else is really cool is that if I get this at just the right place, you can see a little beam, a little radar beam. Yeah, it comes and goes there. Little radar beam. Well, let's zoom in so you can see it better. Little radar beam that shoots out, a quarter, maybe not a quarter, sixth of the way across Texas. That happens with radar when there are really, really large objects like large hail cores. You can get scattering that makes it look like there's something far beyond where the radar can reach, but it's just a large amount of debris. So let's just zoom in here so you can see closer. All right, so now you can start to see this shadow here. That is normally what we'd call a hail core, but it is in direct line with this little bright spot here. Okay, there's the explosion. And the radar site is right here. That's what that black dot is. So there's no actual radar readings directly over the radar. Let's go back and look at this from when you can first see it. So this is at 11:57 p.m. and I believe that this is an Eastern time zone because that's where my software is. So it is 1057, I think. And as we go through, you can see this. I mean, it looks like a fireball on radar. And this is just the intensity reflection of the size of the particles. So it's not actually detecting heat. But look how far this thing goes. And this is going up into the atmosphere. And it finally pretty much dissipates. There's still some of these radar spikes here, so I believe that there may still be some stuff going on the ground, but this is 5:30 a.m., so 5 hours later, there's still evidence up in the atmosphere. Let's try something interesting. So the elevation is 0.3. This is the angle that the radar is leaving, that the beam is leaving the radar. So it's not completely flat. If it was completely flat, we wouldn't get anything that was up in the air. So by having it angled up at a slight angle, it will, here, let me draw a picture. So if this is let's draw red. This is my radar here. It's a big ball on a stand. And if the radar beam went directly flat, you would only ever see things that were at this elevation height, and storms are above the ground and they go up from there, so we've never seen anything in the sky. So there's a slight angle here, and in this case we're looking at the 0.3 degree tilt. So if we look at a different tilt, if it's available like that, you know, maybe 0.6 degrees, we'll see what they have, then we should see different slices of this explosion at the same time. So let's see. Let's back up a little to where it started. There we go. You can even see Starbase named right here. All right, so you see it taken off. This is the 0.3 degree tilt. Let's see if there are other tilts available. There's 4 of them. So let's go up a tilt. And it took us back to the current time, so let's go back. Has to reload all the images. Okay. Yeah, so this is the next tilt up. 12:34 a.m. Let's remember that time frame, 12:34 a.m. You can see this fireball is right over Bayview. So I think if we go up in tilt, we may see a bigger fireball higher up, but let's see what we get. We'll have to go back to 12:34 a.m. because it's going to take us back to the present. So that's tilt 2. Tilt 3 is 1.1 degrees. Just going to load the images. And what was it, 12? There we go. 12:34. This is 12:35 a.m. Okay, so that's 12:35. Still a big fireball over Bayview, but it is kind of cool that we can look at the different tilts. There's one more tilt here. Let's check that out. Tilt 4. In the wrong place. 12:34 a.m. 1:30 a.m. 12:34. So we're not seeing the fireball here. So this is looking much higher in the atmosphere. So this strip of clouds, reflective clouds here, is much higher than it's much higher than what's not below it on the ground. So the clouds themselves look different. Let's zoom out a little bit because maybe we're so high that we needed to wait a little bit longer. 2:45, and we did see it up to 5:30 a.m. On some of the other tilts. So this is actually not showing up. There's this little guy, but I don't think that's related. I think that's a cloud. We'll go back to 12:30 when it happened. Yeah, it's not, there's nothing there. So let's go back to tilt 1, and that's 1.8 degrees. So you could do some math to see how high this thing went. If we measure the distance from Starbase to Bayview, whoops, Starbase to Bayview, it is, why isn't it telling me? It should tell me the distance. Maybe it's this one. Come on, what is going on here? There we go, 16 miles. So 16 miles with 1.8 degrees of elevation. If you were to do a trigonometry problem and you want to find out how high this thing went before it dissipated, this is 16 miles. And this angle here was at 1 point, or no, at 0.6 and 0.9, the ones we can see it on easily, so, or was it 0.3? Let's check it out here. 1.8, we're not seeing it there. Let's go back to one of the lower tilts. Let's try tilt 2. That was 0.7, so, but we can't save that drawing. So we're wondering how high it went. This is 16 miles, more or less, where we saw it sort of dissipate from view in Bayview. And this angle here, 0.7. So we're looking for that angle. And I forget my trigonometry, but that's not too rigorous of a trigonometry problem to figure out how high it went. I just think that's really cool to think about. So let's check this out one more time. And then I'm going to show you one more view from the satellite. So this is radar. Radar is located on the ground. It sends out microwave beams that are then reflected back, and that's what we're seeing here is the reflection. All right, so there it goes. And it goes way beyond Bayview, so that's probably not a realistic distance to see how high it went. All the way up to Kingsville, we're seeing it at 0.7. And that's at 4:30 in the morning. Just for fun, let's go to tilt 3 and go back to 4:30 in the morning. It's not showing me the time. I think I have too many measurements still on. There we go. PM. All right, there goes the rocket ship. Okay, so this kind of disappears from the atmosphere before 4:30, and this is a higher tilt than before, so the height of the explosive remains stayed lower. It didn't get as high as this tilt could see at that distance. So let's go back to the lowest tilt again. One more time, just to see how far it actually went. All right, so, and it goes much further on that slightly higher tilt. We were seeing it here at Falfurrius. I'm not sure if I'm saying that correctly. And at the lowest tilt, the debris goes up to Benavides. Let's see how far that is. Where's Starbase down here? Benavides. 130 miles that debris traveled. That is amazing. You could do all kinds of stuff. You could figure out the speed. This is 4:30 a.m. and the explosion happened, what was it, around 12:30? So this is 4.5 hours later. It traveled 130 miles. What is that, about 60 miles an hour? That's crazy. Wow, that's so powerful. Okay, let's get rid of this. Let's go to, all right, sorry, there's some buffering going on if you are watching it, but let's go to satellite. Sorry, and like I said, this is my first time streaming, so I know it's not going to be smooth. First time using the software here, OBS. First time I've set up scenes with my cute little face inside of a round circle. Okay, this website is College of DuPage. This is satellite data, and there are a couple different options that we can use here. First, you can put a radar overlay on top of the satellite data. Let's just go to the visible. This is what it looks like right now. So this is Starbase Texas is down here in this corner. Let's zoom out a little bit so you can see what we're looking at. All right, so here's the US. That's pretty recognizable. And there's several different options to what time frame you can look for. The default is 24 images, and then you can set the time between each frame to show all of them, all the frames, all the data that the satellite's getting. So this is super fun to just have up kind of in the background and just keep it off to the side, let it go throughout the day, and as time goes by, you can watch your weather change. This is really cool. We can see that there's a big dome here coming in. So this is going to be a heat dome. You may have heard about on the news. There's going to be a high pressure system in there. There's a low pressure system centered probably around here. And so these storm fronts are moving through, creating lots of stormy weather on the east coast today. We can look at an upper level overlay. These are the height levels at 500 millibars, which just means that this is up in the atmosphere about 5 kilometers. And these represent the equal pressure distance. So as air expands, as air heats up, it expands. So the height of this pressure level is going to be higher. I think I see 52 here. Cooler air compresses, so where the air is colder, you're going to see lower heights up here. It's hard to read them. Anyway, so this is pretty cool to just look at. So this is the satellite data. Starbase is way, way down here. Let me stop this. Starbase is way down here in Texas. If we turn on the radar overlay, so this is basically the same thing we just looked at, except it's the whole country. And go back, we're going to need to set this back to 200 and get every other frame because we've gone back a little too far in time for this website. It was at night, and there you can see it right there, sort of streaking up from the southeast tip of Texas right there. I'll zoom in a bit. So this is radar. You can see it's not as bright because this is a composite of the whole US. So what we're looking at is a combination of satellite infrared images, so the heat that's released from the cloud tops and from the surface of the ground is what we're seeing here in gray and white. And it's at night, so there's nothing visible. This is all infrared radiation. If I radar, you just see gray and white. And you can't really see, there's a little tiny streak, I'll probably have to zoom in right there, that you see on infrared, and that's heat being released. If we go back to composite radar, okay, there's a little streak right there. So let's zoom in to a sector that has more detail. Okay, this is super zoomed in. I believe that Starbase is right up here. And let's go back in time. Yeah, there it is. All right, so this is the southeastern tip of Texas, and the rest of this screen is all Mexico. And you can see the explosive remains tracking up there. So what I'm curious about is if we turn off the radar, that's what we're seeing in yellow and green and orange. If we turn that off, then can we see anything on infrared or any of the other channels? So let's turn off this radar, turn off the radar overlay. And so look very closely in that same area, and you do see like a little wisp, little smoky wisp right here. Poof, right there. This is in an infrared channel. There's a couple different infrared channels, so let's see. This is a long wave infrared channel. So this is reflecting heat at a certain wavelength. Yeah, so I still see a little streaky guy right here. There's a lot more noise, but right there's a little streaky guy. Now the time that we're looking at down here, this is Zulu time, or Greenwich Mean Time, 1430. So this is the equivalent of, it's about 5 or 6 hours ahead of us. So this is the right time interval here. But we're also looking at a lot of other clouds going by and the heat that's being reflected from them. Let's try shortwave infrared. A little less messy just because they're not using color. And what do we see here? Yeah, so this is hard too. There's a little streak there, but there's a lot of, I mean, obviously the explosive debris went to the northwest because that's the direction the clouds were moving, and so we're seeing a combination of clouds and the debris here. But you can see everything here is just sort of generally moving up to the northwest. I don't think I saw it on any other ones. Let's look at particle size. What the heck? So this channel can be used to look for dust or pollution, and we're not seeing anything because this is looks like a daytime channel, so there's nothing in the overnight hours there. None of these near channel. Did I see something on the cirrus channel? Cirrus are the high clouds in the atmosphere. Is it loading? Yeah, nothing there. Let's check ozone. Whoops. Doesn't look like we see anything there at night. Oh, we do. There's, again, a little ghosty puff right up here. See it? So that's pretty cool. Anyway, just wanted to experiment with my software, and looks like it works. I'll get used to using it, and maybe you'll watch my video. Thanks.